What's going on, everybody? Welcome back from spring break. This is our last lesson in chapter 9, right? So we have this lesson 9.5, and then next class we're having our chapter 9 review, which means that next week, 1 week from when you're watching this video, next week on Tuesday and Wednesday, we're having our chapter 9 test. That's April 20th and 21st, chapter 9 test. So this is our last lesson in chapter 9. 9.5, segment lengths in circles, right? So last lesson before spring break in 9.4, we talked about angle relationships in circles. Now we're talking about segment lengths and segment relationships in circles, okay? Just a quick review from what we did before we went away to spring break, just a little do now. Right here, this angle is outside, so that equation is angle is equal to big minus small divided by 2, right? Which means that would be 100 minus 30 divided by 2, which comes out to 70 divided by 2, and 70 divided by 2 is 35, right? So angle A would be 35. Right here, this angle is on the circle. The equation is arc divided by 2, so that's just 82 divided by 2, which comes out to 41. All right, so a little quick review of what we did before we went away for spring break. Okay, segments of a chord. If two chords intersect in a circle, the product, right, product means to multiply, of one chord equals the product of the other chord. So in this specific example, right, the length of A times the length of B has to be equal to the length of C times the length of D. And as you can see, we wrote that right there. AB equals CD. A times B equals C times D. Maybe I should have written times instead of putting them together. But some examples, right? Solve for X, right? Here, this one times this one has to be equal to this times this, right? So that means 6x has to be equal to 5 times 12. 5 times 12 gives us 60 equals 6x. Divide both sides by 6. 60 divided by 6 means that x is equal to 10. I almost wrote 6. Here, these two, right, multiplied are equal to these two multiplied, right? So that would become 9 times x minus 3 equals 10 times 18. Right here, we have to distribute. 9 times x gives you 9x. 9 times negative 3 gives us negative 27. And 10 times 18 is 180, right? So that means we're going to add 27 to both sides. All right, we add 27. That gives us 207. And then we divide both sides by 9, right? I don't know what 207 divided by 9 is off the top of my head, so use a calculator. 207 divided by 9 gives us 23. That means x is equal to 23 in that one. All right, here now we have multiple x's, but it's still the same thing. We multiply these two together, right? And then we multiply these two together. So that comes out to 15 times x plus 3 has to equal 2x times 12, right? We multiply across, distributive property. 15 times x gives you 15x. 15 times 3 gives you 45. And 2x times 12 gives you 24x. All right, now we got to combine like terms. All right, that means we subtract 15x from both sides. 24x minus 15x leaves you with 9 x's. So that means you have 45 is equal to 9x. Divide both sides by 9. I'm running out of room, but 45 divided by 9, that would come out to x is equal to 5. All right, that's how you do all of these. Okay, you just multiply the same length, or you multiply the lengths of the same chord to each other and set them equal to the other one. Okay, segments of a secant. Right, to find the lengths of two secant, the product, remember product means multiply, of the external segment and the whole secant equals the product of the other external segment times whole, right? So if we use some colors to represent, right, external, it's written in red, right, times the whole, which is blue. Okay, so red times blue has to equal the other red times blue, right? And I did a slightly different red and a slightly different blue, right? External times whole has to equal the other external times whole. EA, external, times EB, whole, equals EC, external, times ED, whole. Apparently I pressed pause. I don't remember doing that, but I don't know what got cut off. Just know that it's external times whole equals the other external times whole. So EA is the external times EB, which is the whole, equals EC, which is the external, times ED, which is the whole. So hopefully not too much got cut off there, but we'll see how it goes, I guess. All right, so external here, this is the external, which is 4, times the whole, which is 4 plus 5, has to equal, right? Again, if we use blue, but a little bit different blue, the external times a slightly different, maybe like an orangish, right, equals the whole, right? So external times whole equals other external times whole. So external here is 3 times external, our whole here is 3 plus x, has to equal the external here is 4 times the whole is 4 plus 5, which is 9. All right, so we distribute across. 3 times 3 gives you 9, plus 3x equals 4 times 9. That gives you 36. All right, look at me, still counting on my fingers. You couldn't see that, but I was doing that. Now we subtract 9 from both sides. You end up with 3x is equal to 27. Divide both sides by 3. And you get x is equal to 9, right? So x would equal 9 there. Okay, here, right, again, blue is our internal, or sorry, blue is the external, red is the whole. Right, so that means we would write 6, which is our external, times whole would be 9 plus 6, which is 15, has to equal external here is 5 times the whole, if we use another red, the whole for this one is 5 plus x. Okay, so 6 times 15, I don't know what that is. Multiply it out on a calculator. 6 times 15, that gives us 90. 90 is equal to, we have to distribute, 5 times 5 is 25 plus 5x, right? So then we subtract 25 from both sides, right? 90 minus 25 gives us 65 equals 5x. Then we divide both sides by 5, 65 divided by 5, x is equal to 13. Okay, and one more, right? External is 6 times whole. The whole is 6 plus 4, which is 10, has to equal external here, which is 5, and the whole is times 5 plus x. Okay, so 6 times 10 is 60. All right, look at this. It ended up being the same thing. 5 times 5 is 25. 5 times x is 5x. All right, subtract 25 from both sides. 60 minus 25 gives you 35. So 35 is equal to 5x. Divide both sides by 5, and x is equal to 7. Okay, that's how you do those problems there. Segment of tangents and secants. With a tangent line and a secant, the equation is tangent squared equals external segment times whole secant, right? So it's similar, right? Whenever we're dealing with secant, it's still external times whole, but now when we have tangent, it's tangent squared. So EA, that's the tangent, squared is equal to EC, which is the external, times ED, which is the whole. Okay, so again, if we do the tangent here in green, remember it's tangent squared equals external times the whole. All right, so tangent squared would be 7 squared equals external here. Again, I guess I should use better colors. External is 5 times the whole is 5 plus x. There ends up being a lot of 5 times x's in here, right? So 7 squared ends up being 49. 5 times 5 is 25. 5 times x is 5x. All right, 49 minus 25 gives us 24 equals 5x. 24 divided by 5. All right, that's going to end up giving us a decimal, but that's okay. Nothing wrong with decimals. X is equal to 4.8, right? Because we divide both sides by 5 there. So that's your answer there. Okay, here we end up being a little bit different, right? So tangent is 16. Tangent squared is 16 squared, right? If we do external, which we've been doing in blue, the external is x times the whole. If we write that in red, the whole is x plus 8. All right, so now we have to distribute. Well, actually, let's do 16 squared first. 16 squared ends up being 256 equals, we have to distribute. X times x gives you x squared, and x times plus 8. x times 8 gives you 8x. Okay, now we end up, if we subtract 256 from both sides, we end up with 0 is equal to x squared plus 8x minus 256, right? And again, this is something that you should have learned in Algebra 1. There's multiple different ways that we can solve for this one. We can either use the quadratic equation, x equals negative b plus or minus, well, what is it? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Look at that, still remembering the quadratic equation. Or you can factor it as well. In all honesty, you're probably not going to end up with too many questions like this in your homework or in your test, right? So I'm going to just leave it at that. You would either use the quadratic equation or factor and then solve for x as well. And as we can see, this problem is going to end up being exactly the same situation. So I'm going to not do that one, and we'll just leave it at that. Okay, but this is a good representation of what you need to do and how you would solve there. Okay, segments of tangents and other tangents. If two segments have the same exterior point and are tangent to a circle, then the segments are congruent. All right, so we see that they go from the same exterior point. Both of these are tangent to the circle. That means they have to be congruent. They're the same length. That's it. That's all we're doing there. All right, so that means if we look at these examples, right, we know that these two tangents are congruent to each other, and if we're going to solve for x, that means they're equal to each other. We set it up as 2x minus 5 has to be equal to x plus 15. Subtract x, that leaves us x minus 5 equals 15. Add 5 to both sides, we get x is equal to 20. All right, these are congruent, so therefore we set them equal to each other. 2x plus 9 equals 3x plus 6. All right, subtract 2x. That gives you 9 is equal to 3x minus 2x is x plus 6. Subtract 6, you get x is equal to 3. Okay, that's it. That was our first lesson back from spring break. I hope you had a wonderful break. Make sure we come ready to learn and prepare ourselves for the Chapter 9 test, because the Chapter 9 test is happening next week. Go Mustangs.